Hello and welcome into another episode of Data Center Frontier's Quick Chat. I'm Matt Vincent, Editor-in-Chief with Data Center Frontier. And today we're here speaking with Manja Thessin. Manja is Market Manager of Market Strategy and Innovation with AFL. Welcome in, Manja.
Welcome, Matt. So great to be here with you today.
Yeah, we're so happy to have you here. Well, of course, today's topic is data center optical infrastructure optimization in the AI era. So there's a lot to talk about there. So I'll start off here, Manja, with our first question for you, which is wanted to ask, how important is it that data center operators look at their interconnects in readiness for AI traffic loads? Um, and not just the cooling and the power. Can you elaborate on the specific challenges and solutions in the area of interconnects?
Yeah, absolutely. So interconnects are extremely important in AI-driven data centers. And while cooling and power are absolutely crucial, it's really the interconnect networks that truly enable the magic of AI to happen at scale. So when we imagine trying to get tens of thousands of processors to all work in harmony in order to support AI models with trillions of parameters, and that's really the reality of modern AI workloads. And it's a massive challenge that demands robust network infrastructure. And then we're not just talking about fast, we're talking lightning speeds here. Each high-end GPU in a typical AI cluster uses 400 gigabit interfaces today, and that's just really the beginning. We're seeing rapid adoption of 800 gigabit Ethernet, and with 1.6 terabit Ethernet already peeking over the horizon. So this isn't just about bragging rights and who has the fastest network speeds. It's really enabling the kind of seamless, low latency, high bandwidth communication that AI workloads are going to demand. And Gen AI has really turned the data center world on its head. The facilities now need exponentially more fiber than their traditional counterparts. And why is that? And that's really to support those high density interconnects that GPUs and accelerators can't live without. So we're talking about systems that shuffle enormous amounts of data very quickly and reliably, and not just within a single data center anymore, but across multiple facilities. So, and then we're seeing the AI models growing more complex, and let's face it, they're not getting any simpler. So the infrastructure really needs to keep pace here. We're seeing networks that span across large buildings where we're seeing these massive clusters being built, entire campuses, and with interconnects now stretching up to 10 to 20 kilometers between nodes. So this level of scalability isn't just a nice to have anymore. It's really becoming a necessity as data centers deploy these distributed clusters across regions. So the bottom line here, really, cooling and power are absolutely vital, but they're only part of the equation. So without that high performance, fiber dense network fabric, even the most advanced data centers will struggle to keep up with the AI demands. So interconnects are really the keystone that connects everything together.
I really think you're right. And of course, you mentioned the fibers. And I wanted to ask, with the increasing density of fibers in data centers, what methods would you recommend for operators to densify in an organized, logical manner? And how can methods like these improve efficiency and manageability?
Yeah, really today with the various challenges that AI workloads bring to our data center designs, we have to kind of get creative with our connectivity strategies. So I'll talk about a few things that can help operators to densify the fiber infrastructure, but at the same time, keeping things organized and efficient. So let me start by talking about the really game-changing, very small form factor connectors. These tiny connectors like the MMC and MDC are redefining what's possible in fiber density. So we're now able to put thousands of fibers into just one single RU panel. And that's the kind of density that we weren't even able to imagine just a few years ago. But when we talk about hyperscale data centers and these AI-focused clusters, every millimeter of rack space counts. So this is a massive leap forward. And then structured cabling, that might sound like a little bit of old news, but it's more important than ever. We're seeing ultra-high density solutions that leverage pre-terminated fiber cables for interconnectivity. So that's not just about keeping things neat and tidy, it's really thinking about making maintenance and upgrades and installation much easier. So even just imagine trying to trace one cable out of thousands during an outage or a Mac that quickly turns into a nightmare. So structured cabling is very, very important. There's also a consideration around flexibility. So we're moving very quickly in a data center world where we're constantly changing and upgrading. So modular designs are becoming the go-to approach for fiber management. So these systems let you expand incrementally, whether you're adding more fibers or upgrading to a different connection without tearing out your existing setup. So it's thinking about future-proofing your infrastructure. And one thing that really gets me excited are some of the cutting-edge AI-driven cable management tools that are becoming real now. So these are smart systems that actually analyze your data center layout in real time. And they even suggest optimal cable paths and predict potential issues before they happen. So it's really cool stuff. And then, of course, we have to think about heat. When we see higher fiber densities, there's really a need to rethink our fiber management systems. So those are becoming more smart about cooling. Some are even integrating liquid cooling pathways directly into the infrastructure. And then, of course, we can't forget about optimizing our cable lengths and routes using custom length cables or the pre-terminated solutions I spoke of. That can really significantly improve the airflow around your equipment. And then manual labeling, that as you kind of think about doing that with thousands of cable trunks and connections, it's really becoming a very laborious effort. So automated systems that use RFID tags or IoT sensors are taking over, and they're tracking every connection in real time. That, of course, helps not to only just reduce human error, but really gives you up-to-the-minute accuracy when you need to troubleshoot or make changes to something. So managing fiber density isn't just about cramming more cables into racks, it's really about doing it smartly. So by leveraging some of these advanced technologies and strategies, data center operators can really improve the efficiency, scalability, and reliability of their network infrastructure and prepare for future demands of AI, 800 gigabit networks, and really beyond. So organization is not a nice to have anymore. It's really essential to keep your data center running smoothly and ready for whatever might come next.
Absolutely. That white space in the data center is definitely getting crowded, which I think is what we're talking about. So I wanted to ask, could you explain the concept of white space optimization in data centers and tell a little bit about what the potential gains from leveraging such an approach might be and how it can contribute to a data center's overall performance and scalability?
Yeah, Matt, absolutely. So white space optimization is really about squeezing every ounce of performance out of your data center footprint. So let me break this down a little bit and explore why that approach is becoming such a game changer. Let's talk about cooling for a minute. Today's high-density racks are pushing 30 to 50 kilowatts or even higher in some of the new AI cluster environments. And of course, traditional air cooling just can't keep up with those high demands. So we're seeing a lot of shifts towards more efficient cooling methods, such as direct-to-chip cooling, immersion cooling, rear door heat exchanger, and all these technologies are really are getting up and close into the data center infrastructure, which help to drastically improve the efficiency of our compute network. So it's becoming very important to optimize the airflow and implement containment systems so to really see those significant reductions in energy costs that are required and eliminate those hotspots. So while white space optimization is about maximizing the compute power per square foot, here we're talking about cramming more processing into smaller spaces without compromising performance. So we're not just talking about savings on real estate or space costs anymore. And here's where things get really interesting. Smart data center operators are always thinking ahead, so leaving room for tomorrow's technology today. So we're now seeing facilities that are allocating extra space for future AI accelerators, quantum computing infrastructure, and even next generation cooling systems. So this foresight really means that when the next big thing hits, you're not scrambling to retrofit and rebuild. You're ready to plug and play. And of course, let's not forget about the people that are working in these spaces. And optimized white space really helps technicians because there are clear pathways. There's a logical layout. Everything is well labeled. And these very seemingly simple factors can significantly reduce human error, which, let's face it, is still a major cause for downtime in the data center. So some cutting edge facilities are even experimenting with augmented reality to help technicians visualize cable routes and equipment placements before they even lift a finger. So in the age of AI, which comes with unpredictable workloads, being able to scale quickly is extremely important. So white space optimization really embraces that modular approach and allows for incremental growth. When you need more racks, no problem. Additional fiber connections, easy. An upgraded power or cooling system, you have the space and the provisions to do it. So white space optimization isn't just a trend anymore. It's really a fundamental shift in how we approach data center design and management. So that focuses on efficiency again, scalability, and being future ready.
Well, these are all great points. Thank you so much to you, Manja, and to AFL for joining us here today.
Yeah, thank you, Matt. Really appreciate the opportunity to be here with you today.
Absolutely. It's been a pleasure. We'll see you next time on another edition of Data Center Frontiers Quick Chat videos.